Hello friends, welcome again all of you on your channel, that is JE Physics Maniac. So here for the first time on request of you people, I am starting the JE Advanced 2021 series. So on the first question, here we will try to figure out the equation of trajectory. It's a very common question and there are few common part of this question which are known to everyone. We will not do that. We will try to figure out something different. So here is the question. You can see that there is a equilateral triangle ABC where the sides are given to be A, and from each vertex A, B and C, there are three particles of equal mass M. They started moving towards the other with constant speed, right? And ultimately we all know that that ultimately they will meet at the centroid by making some kind of trajectory like this. That's we know, all of us we know that. I'm not going into that. Where will they meet? What is that displacement? I am going to figure out why they are making such kind of trajectory. Can we mathematically find it out? Yes, we can. Let's see. So before proceeding, I can tell that rather than giving the explanation where will they meet in terms of relative velocity, we can have a very nice explanation that here in this case, if you think about the system, total external force on the system is equal to 0. So in the absence of the external force, we know that center of mass acceleration is equal to 0, and hence shift in center of mass is also equal to 0. So when the particles are at the vertex, the center of mass is at the centroid. So they will meet in such a way finally so that the center of mass stays at the centroid. So where will they meet? They will meet at the centroid. So nice explanation we can get from center of mass momentum collision. Now, next is, can we find out the equation of trajectory? Yes, we can. Let us see how. So in general, I will take a case that there are two particles A and B, and this is the line joining between them. Let us say I'm taking this is L0, and initially B is moving in that direction with VB, and A is moving in this direction with velocity VA. What I'm trying to do now, I'm trying to observe from this point B. So I'm fixing the observer at point B, and I will observe the motion of A with respect to B. So now here you see that motion of A with respect to B will be equal to velocity of A with respect to ground minus velocity of B with respect to ground. All right, fine. That is equal to, this is VA already, and if I take the negative of this VB, it will come in that direction, which is there in the diagram, right? So now the resultant will come in this direction. So now if I take a neat diagram, the neat diagram is coming like this. Now my observer is fixed at point B. So A point is moving in that direction with velocity VAB. It will have two components. One is perpendicular to the line joining AB, and another one will be parallel to the line joining AB. Correct? Fine. These two have different roles to play. As I've written over here, VAB, this component always tries to rotate point A about B. And this parallel component, this is towards point B. So that means what it is trying? It is trying to minimize the separation between the line joining A and B. So it's a very complicated kind of motion. That means the point A will rotate as well as it will try to decrease the separation between the 2 points. So now I'm going to the mathematical part. So I've taken a small elemental portion. This was the initial separation L0. After some time it has come here, and this angle is d theta and this length is L. So this is almost linear. I am taking it to be L d theta, and the decrease in separation, I am taking this, if I drop a perpendicular, the decrease in separation is coming to be minus dl, let us say, right? Correct. So let us check. So here in this case, I can write L d theta. In the direction of L d theta, perpendicular component of velocity is there. So this is responsible for L d theta. So I'll write L d theta is equal to V perpendicular into dt. Also, along the line joining AB, V parallel is responsible. So along the line joining, I will write minus dl. Minus sign is why? Because the separation between them is decreasing. That is equal to V parallel into dt. Now, if I divide these two equations, if I divide this and this, we will get minus of dl by L is equal to d theta will go on this side, V parallel by V perpendicular into d theta. So after suitable integration, finally we will get the result that L is equal to L naught e to the power minus integration 0 to theta V parallel by V perpendicular into d theta. Wow. So now you can see it is an exponential decay curve. Right? Now you can understand why the curves were like this. Why the curves were like this. Correct? Now, can I get the exact precise equation for this particular case? Yes, I can. For which I have taken this point A. and I'm trying to figure out the velocity of A as observed by B. So for that I have done vector method, as you can check over here. So I am taking minus of VB. This is VB initially in that direction. So minus of VB is in this direction, and I have taken this resultant. This VA and VB are equal in magnitude, so resultant will bisect. So this angle was 60, so this is 30, this is 30. Now I am dividing into component. This is V perpendicular and this is V parallel. All right, fine. So from there, V parallel is coming to be, see, this angle is 30 degree. So V parallel is VA by B cos 30 degree. V perpendicular is VA by B sin 30 degree. Now I am directly incorporating into the result. So here you see VAB cancels out, right? Now this is obviously root 3 by 2. This is half. It cancels out. It becomes root 3. So I will get R equal to L naught means A, the side that we have taken in the beginning only. As you can check here, I have taken that AB equal to BC is equal to CA equal to A. So there L naught is equal to A. So R is equal to A e to the power minus root 3 into theta. This is the equation of trajectory for such kind of motion. Again, it's a new thing, unique thing. I hope you have enjoyed, and if you have enjoyed, please do like, subscribe and share. Your cooperation is highly needed. Thank you very much. Thanks all.